vocabulary and terms you need to understand from topic 1 in geometry. Reflexive property. Reflexive property is basically stating that something is congruent to itself or equal to itself. So an object is congruent to itself. For example, this object, segment AC, is part of this top triangle. AC is also part of the bottom triangle. So they're objects part of two separate triangles, but they're actually the exact same thing. So when they're exact same item, then you can say AC is congruent to AC. This is used often with proofs. So the reflexive property. Multiplication property of equality. I love this example. Multiplication property of equality, and most of the properties of equality you will have used in Algebra 1. Unfortunately, you forget them, but that is when you multiply the same thing to both sides of an equation and it doesn't change. So if you look here, see how there's 15 and 5 in the denominator, and you want to get x by itself. So x is divided by 5, so you have to do the opposite. So that would be multiplying by 5. But when you multiply by 5 on both sides, or any number, then you are using the multiplication property of equality. Angles on a line. Visualize an actual line, angles on them, all from one point. So here's the one point on this line. If you had a line and there were angles down here and angles down here, yes, they're on the same line, but they don't count. They have to be on the same line at the same point. So here's the line, and one side of that line totals 180 degrees, and they're considered supplementary. So some textbooks, some teachers teach angles on a line. Anytime, however many angles you have, they add up to 180. They might say angles on a line. They could also say supplementary. Right triangle. Triangle that has a right angle. A right angle is 90 degrees. So here's a triangle, a right triangle. Here's the 90 degrees. The important thing about a right triangle is that A and B, the two sides that touch the 90, when you're using the Pythagorean theorem, for example, those are the two legs. C is the one that doesn't touch the 90. It's always going to be the longest, and it's the hypotenuse. Base angles. An isosceles triangle has two sides that are congruent. So if you had base angles across from this side, right here, angle C, and across from this side, angle B, those two angles are congruent. So in an isosceles triangle, both base angles, this angle and this angle, are congruent. Where the two congruent sides meet, this is actually called the vertex angle, and that's the one that's different in an isosceles triangle. The exception would be if it was equilateral triangle, because they would all be the same measure. Substitution property of equality. Substitution is when you take something and replace it with something of equal value into an equation. So substituting, think of a substitute teacher. When your teacher's not here, they are gone, and a substitute comes in supposedly to replace or be equivalent to the original. We know it's not always the case, but in math, it is. You can only substitute with equal value. So substituting a number or expression. So if triangle equals -2, then 5 plus triangle equals 3. You take the -2 and substitute it where the triangle would be. That's substitution. Some teachers accept just substitution in a proof. Others require substitution property of equality or substitution property of congruence. Angles of an equilateral triangle. I kind of mentioned this before. Equilateral triangles have three sides that are congruent. And if you have three sides that are congruent, each of those angles are also congruent, creates an equiangular, means equal angles, triangle, and they all would be the same measurement, and that's 60 degrees. So basically, triangles all together, their sum is 180. So divide that by 3, you get 60. So 60 degrees are in every equilateral triangle, in each angle. Supplementary angles. Supplementary angles and angles on a line are very similar. So I'm going to show you the visuals. If you have two angles anywhere, they could be apart from each other. If you have two angles that combine, their sum is 180, they are considered to be supplementary. But if you have a line and those angles add up to 180 on a straight line, that's also supplementary. So those rules can be used interchangeable, but don't call angles like this angles on a line because they're not on the same line. But it's okay to use supplementary if they are on the same line. So talk to your teacher which one they prefer. Addition, property of equality. Again, adding things to both sides to keep that a balanced equation. If I'm going to add 7 over here to the equation, I have to add 7 to this side of the equation on the other side of the equal sign. So look here, I have a minus 16. You have to undo or do the inverse operation of minus 16. So that means you add 16 to both sides. So that's addition, property of equality. Linear pair, supplementary, angles on a line. These are all so close and can be interchangeable depending on the teacher, but other teachers do not allow it, so be careful. A linear pair is just that. It's a pair, meaning 2 angles that make a line. So they have to be on a line and there can only be 2 of them. So an angle here, an angle over here. That's it. If there's a third angle, it doesn't count as a linear pair, but it might count as angles on a line. Or you could say it's supplementary. So all of those terms still mean that they add up to 180. You just have to be careful of where they're located. Complementary angles are very similar to supplementary angles, except complementary angles add up to 90. So they can be together, all together to make a right angle, to make 90 degrees, or they can be completely separated. They still are considered complementary angles. They have to add up to 90 degrees. Subtraction, property of equality. These properties of equalities you're going to use all year long, so learn them. Subtracting the same thing from both sides of an equation. So it's x plus 6. To undo that, you have to subtract 6 on both sides. And when you subtract the same number or same thing term from both sides of an equation, that is called the subtraction property of equality. Midpoint. Midpoint is exactly what it says, midpoint, point in the middle. So it's exactly in the middle. So if you have 2 endpoints of a segment, the midpoint is exactly there. There's a formula to go with this we will talk about later in a different video. Pythagorean theorem. Lots of kids know the Pythagorean theorem as a squared plus b squared equals c squared, but that's only part of the theorem. The theorem actually says if a triangle is a right triangle, that first part is critical. If it's not a right triangle, you have no business using the Pythagorean theorem. So keep that in mind. It has to be a right triangle. Then you can use a squared plus b squared equals c squared, where c has to be the hypotenuse or the one not touching the 90. A and B are interchangeable. This could have been A, this could have been B. The A and B just have to be the 2 legs or the 2 sides that touch the 90 degree right there. Collinear. I hope you can see the word line right there, L-I-N-E. Co, meaning it's sharing. So these are points sharing a line. So A, F, B, these 3 points are collinear. These other ones are not. Okay, so they have to be on the same line. If I drew a line through AG, right through those 2 points, then A and G would be collinear, and the other points would not, on the same line. Angle bisector. First, you have an angle and you have to bisect it. Bisect means to cut in half, perfectly in half. So this could be a plane, a line, a ray. It's some object that is perfectly cutting this angle in half. So here it is, OP right there, this segment is cutting AOB, this huge black angle. It's cutting it perfectly in half. And what it does is it is creating 2 congruent or equal angles and angle measures. So an angle bisector cuts an angle exactly in half. Perpendicular bisector, that word bisector is coming back again, cutting it in half perfectly. Perpendicular is like intersecting at a 90 degree angle. It's exactly what it is. So, you know, parallel, they never intersect in the same plane. Perpendicular, they intersect, but they have to intersect at a 90 degree angle. So intersecting at a 90 degree angle is the perpendicular part. Bisecting is the cut in half part. So let me show you a visual of this. AB, the segment AB, see this tick mark? That means this tick mark and those are showing congruence. So from A to D and B to D, those are congruent. So a perpendicular bisector is creating 2 congruent segments. So because it's a perpendicular bisector, this segment over here and this segment over here are the same, and it's creating a 90-degree angle. Conjecture. Conjecture is one of those things that it's like a well thought out plan with some reasoning, or I think this because. A conjecture in science is called a hypothesis. So in math, it's called a conjecture. So it's similar to in science, but it's a well thought out or educated guess. Counterexample. A counterexample is one example, all you need is one, that proves something is false. So you just need one example to prove something is false. So an example that shows the statement is false, any statement. Distributive property, again, this is one that you use in algebra, and you can say distributive property of equality is totally acceptable and it actually is encouraged. So you might even be allowed to say, depending on your teacher, just distribute. That might be okay as well. Talk to your teacher and know what they want. Distributive property is basically a multiplication. You are multiplying whatever's on the outside of the parenthesis or the grouping, it could be brackets, outside of the brackets or grouping, you're multiplying to each thing in that grouping. So 2x, you're multiplying by each of the terms. -3, you're multiplying by each of those terms. Okay, so you are distributing or multiplying to everything in those groupings, in the parentheses. Conditional statement is literally a statement that says if, then. The if, that's right after the if is called the hypothesis. Right after the then is considered the conclusion. So here's an example. If I do my work, then I will get a good grade. So if, then. Converse. The converse, I want you to think of Converse shoes, someone wearing Converse shoes on their feet, pretend like these are feet. And the converse just takes the order and switches them. So it's if, then. The if went to the then spot, the then went to the if spot. So hypothesis and conclusion are flipped. So if I do my work, then I will get a good grade is the original conditional. The converse is if I get a good grade, then I did my work. So that order of hypothesis and conclusion is switched. Just order, nothing else changes. Inverse. The inverse, take the original conditional and negate the hypothesis and the conclusion. So it's the opposite. If it's positive, then you negate it. If it's already negative, then you make it like a positive. So for example, if I do my work, then I will get a good grade. The negation, if I don't do my work, then I won't get a good grade. Okay, so it's making all the hypothesis and conclusion negative or the opposite of what they already are. Biconditional, this puts together two things. It puts together the regular conditional and the converse together. So it works both ways. And they connect it with an if and only if statement. So instead of if, then, you start with a hypothesis, I do my work. If and only if, I get a good grade. So remember, a biconditional has to have the if and only if somewhere in the middle between the hypothesis and the conclusion. Contrapositive, this is the last one. Contrapositive, it's taking the original conditional statement, it switches the order and negates. So it's putting the inverse and the converse together. So if you see this, if I do my work, then I will get a good grade. If I don't get a good grade, then I don't, or I didn't do my work. So the order switched and it became negative. Okay, at the end of the slide, here it is. We have blank slides for you. If there are any terms or formulas or anything that you don't know and you need practice on, add them to this slide and then you can practice those as well. I hope that helped.